Okay, testing. Oh, yep, there we go. All right. So we are doing, I'm doing my first stream, and for this stream, I'm just gonna do something simple. We're gonna make a DLL injector. It's been made a bunch of times already. You look it up on the interwebs. DLL injector, maybe on Windows. Yep, and you can see that there's a bunch of things for DLL injectors. What I'm gonna try to do with this DLL injector is I'm gonna try and make it function a little bit more like LD preload on Linux. So on Linux you could do LD preload equals my cool so.so, and then your like cool executable. Well, I guess you would just say that. Whereas on Windows, I want to say the program I'm going to be writing to do this DLL injection is called Yaddy, yet another DLL injector. So you should just be able to run this. You should be able to run this, my cool DLL.dll, and then my cool exe.exe, and this should function very similarly. That's the goal here, and we'll see how far we get with that and see what we can do with that, and it should be a lot of fun. So yeah, first things first, I just kind of create the new process. You input DLLs, and then you have the command line over here, and so if I make this, it makes it just fine. And if I try to debug it now, I can launch that, and forgot why that didn't work. Oh, well, it's just passing that directly. Oh, like that. Okay. How about I just do the direct one? Windows System 32.exe. Yeah, I'm just going to inject into command.exe for now to test. Okay, let's try debugging it now. You can launch it, and if I go here, you can see I'm in command.exe, and I launched it from this. So that's all we're doing for now. And now I'm going to try and actually exit the application and then inject into that. So I'm going to make a new thing called LoadLibraryRemote A, and I'm going to take... Is it an H process or a handle? I think it's just a handle. Get current process. Okay, yeah, it's a handle. So I can say handle H process. I can specify the library name right here. So now how this generally goes is you can't just pass, there is a function called create remote thread. If I look that up right now, create remote thread. And so you can pass it a parameter, and you can specify a process, and then the actual function itself, and there's a function called LoadLibrary, where it happens to take just one parameter, and so we can actually pass it this function. Now, the astute among you might realize, hey, if we're executing this in the remote process, another process besides our own, don't we have different virtual address spaces? We shouldn't just be able to pass that right here, right? And normally you would be right, but Windows is kind of cursed in that if you pass this, or if you specify something from kernel32.dll, those addresses are actually the same across all processes. And also ntdll, yeah, that one too, where it's loaded the same in every process. So you can just kind of like pass the address from your own address space to the other process's address space, and it's actually in the same place, so you can just kind of get away with that. However, obviously this library name is not valid in the other process's address space, so what we actually need to do is we need to create a remote Yeah, I think I'll just stick to Windows calling convention and leave it at that. It's a silly thing. I didn't really need to do that, but sometimes I'm like that. It's weird. Virtual alloc-ex. Yes, there's a function called virtual alloc-ex, which allows us to allocate memory in another process. How nice. Let me actually put it side by side so I can sort of switch between everything a bit better. Actually, let me also check OBS Studio. Where is everything? Okay. Yes, okay. So that looks fine. Actually, let me check streaming settings too. Yeah, streaming's still going strong. Okay. So virtual alloc-ex, and what that takes is really interesting formatting by NeoVim over here, but then you feed it the process and you feed it the lib name, and then no, wait, no, we don't want this, right, because we want it to do it for us. And then we take a size, which is str_len. Did I have string.h? No, I don't, so I should include string.h. Str_len. What is it, lib name? Yeah, there we go. FL allocation type. Right, I forgot what the allocation types actually mean. Oh, right, yes. So I want to commit that. There we go. And then FL protect, that would be read write, correct? Yes. Page read write, yes. Page read write. And that's it. Okay. So we have virtual alloc-ex, and then I have to check the return value. It's null, right? Yeah, no. If LP remote name is equivalent to null, we are going to say, we're going to make an error, and we're going to say failed to allocate memory in remote process. Yep. Make it a little bit bigger so I can sort of get away with that. I guess I can also do it like this. Yeah, there we go. Return false. Well, actually, what I'd rather do is at this point use a go-to, and we're going to say, we're going to call this done. Go to done. And so now I can just say bool status equals, or bool success equals false. No, I'll do a lowercase. Yeah. Probably going to reuse that label a lot, so might as well. Load done. NeoVim, can you not please? If LP remote name does not equal null, we're going to virtual free that. Virtual free EX. Yep, that should work. Oh, interesting. You can specify a size for that. I don't think virtual free is able to do that. Well, yes, virtual free is able to do that, actually. But if you're like decommitting something, I think you have to like specify 0 or something like that. Yeah, like mem release, you have to make it 0. Probably the same thing in here as well. Yep. Okay, so now I want h process mem, or what is it? LP remote name. Mem decommit. Or yeah, so that's 0, and then this is mem release. And then in addition, you can do that. Right, that's placeholders. That's a different thing. You don't need that. Where is it? Yeah, so that should be it. Return success. There you go. And so now I want to write this name into the remote name. Again, this is, speaking of which, this should be +1 because I want room for the null byte. Yeah, so we want to write into the process memory. So there's a API call called write process memory. And so I can say if not write process memory h process what was the base address again? Wait, what does the base address even mean in this case? In the specified process. Okay. So LP remote name and then buffer. Yep, so now we have LP lib name. Yeah, I'm just going to put that in a separate variable just so that we don't have to specify that every time. Name. Okay, so I'm going to specify null for that because that should always work. What did all? I mean, I guess technically, if the process unmapped its own memory, then again, if we sort of look here, we are suspending the process, so there's no way it should be able to do that. And anyways, it's more like an edge case. I don't know. I'm not really that bothered by it. Fail to write library name and remote process. %e. Get last error. And then get last error is another Windows API call that actually gets the error of other API calls here. Go to load, done. Okay. After that, now we should be able to create the remote thread. Create remote thread. Ah. Why does Neovim do this? Anyway. So each process, no thread attributes. You determine the stack size. The kernel determines the stack size. Or rather, the library determines the stack size. It doesn't matter. Something determines the stack size. Right, what's the start address again? Right, load library. Handle hthread. I guess maybe I can do something like this. Yeah. Okay. LP parameter. Right, what's the parameter? Right, it's the remote name. Creation flags. Okay. Create suspend? No. Yep, just running. LP thread ID, right? That would be nice. Wait, actually, do we need it? No, we don't. Okay. Yep, I just want to handle. Don't care about the thread ID. Let me actually put all the parameters in its own line. Why not? If hthread, and then it's null if it's an error, right? Yep. You might be wondering why I'm always checking for null, right? Like, that's normally an error condition, right? Well, if I go to create file A, yep, its return value is invalid handle value, which is actually not null, because Windows is great. I love Windows so much. So that's why I'm always skeptically checking whether these sort of handles are null or not. Because depending on like the time of day, Windows actually decides whether it wants to use null or invalid handle value. Anyways, so thread is null. Then fail to create remote thread for load library %e. Get last error. Go to load, done. Okay, after this, I should just be able to wait for the thread. Yeah, there's something wait for single object. Waiting for remote thread to finish. Actually, I don't need this. Wait for single object. H process, not H process, H thread. We want to wait for the thread to finish. And then infinite, right? And then we want to get the exit code. Get, what is it? Get exit code thread? Yes, it is. Thank you, Google, for auto-completing that. Wait, bool, what does that do? Okay. Keyword dw exit code if get exit code thread each thread and exit code. Okay, so OBS Studio decided it wanted to have a heart attack, I guess. It disconnected and then it reconnected again. So we're back. Great. Anyways. And we're going to do a debug message here. Remote load library thread. Okay, something hates me. Something hates my internet. Something hates my connection. I don't know. It's great. Let's see. And then I want to warn. All right. Could not get exit code of thread. Remote load library. Get last error. And then that's not really an error condition. We don't really need the exit code. It just would be an IC. So then I can close handle. That's what it's called, right? Close handle. Yep. Close handle to the thread. H thread. Oh, right, that's no, that actually is an error condition. Okay. Now, what load library does is okay, yeah. Let me close some MSDN tabs real quick. Yes, it returns an H module. So that's actually our exit code right here. That's what it returns, an H module. So we're going to say if H module DW exit code is equivalent to 0, I'm going to say success equals DW exit code does not equal 0. We also can just close the handle right here. Success. Or if not success, then an error. Fail to get exit code. or load library failed for some reason. And then we actually can't get an exit code right here, because we sort of lost that when we exited the thread. So if it fails, we're going to have a very fun time debugging that. Yeah, that should be fun. Actually, what would be even better is if I went here, right, if h thread is not equal null, then I can say this. Yeah, so now I don't even have to manage that. Okay, so we can make this. Great, okay. Syntax here, wait, okay. Let me make it again. So let's deal with 53. Okay, what's the syntax here? Oh, am I not supposed to have that? Okay. I'm used to other languages just being able to put commas there. Wait, no, there's still a syntax here. Why would there be a... Did I write it? Oh, that must have been it. I just didn't write it. Okay. Oh, that's true. That's not a constant. Okay, so we can do that. Wait, what was the here again? Oh, I forgot to write it again. Okay. Create a remote thread cannot convert an argument 4 from that to... Oh, that's true. Okay. What's it? LP... What do they call it? LP thread? Start routine. Make. So now it's 76. Oh, I forgot a comma there. Forgot a comma here as well. Okay. Great. So everything compiles. Now I want to actually load a library. So I think I had an injection. Yeah, I had an injection, which tries to like print out all the module names. So we can try and do that. I'm gonna make it using cl/ld injection.c. Should put an exclamation point there. Oh right. cl/ld injection.c psapi.lib. There we go. And I'm going to do that, and what is it, injection.dll, Windows 732. How about if we change the debug script I have? Injection DLL debug. Alright, so that should launch that. And then I realized I didn't actually do that yet. By that I mean I actually inject the DLL. Okay. Debug F. Injecting something. Injecting DLLs. And then for int args, int I equals 1, I is less than argc minus 1, I plus plus. We're doing less than argc minus 1 because you see up here the command line, right, the command line that we're actually using to invoke is that last argument, so we don't want that. Debug F. Well, actually, how about we do this? Yeah, that'd be better. Injecting %s char star DLL name equals argv I. Don't need a new line. DLL name. If remote load library DLL name. What is it? pi.h process. Yes. Terminate process. Fail to load library or fail to load library %. Well, no, we don't. I don't know why. And then we're just gonna terminate process. And then we're gonna break. And sure, why not? Let's do 1337 as an exit code. pi.h process. Yep, that should be good. Also, I named that with an A, so let's do that. Okay. Remote. Oh, I forgot to. Okay. There we go. Good. Okay. I actually kind of liked that. Yeah, okay. Remote. Okay. Oh, debug. Okay. Okay. Oh yeah, and you can see it. It actually worked here. So you see all the individual module names. You have command, loads into DLL, kernel32.dll, kernelbase.dll, ucrtbase.dll, injection.dll. I don't actually know if command prompt uses the C runtime. I think it might have been the injection that loaded that. I have no idea. No way, because if it was because we use PS API. So if we were the ones who used UCRT base, I think this would be loaded after. Okay. Anyways, load library actually did the thing successfully. Now, I think this is kind of a good place to stop at this point. Like, it's my first stream, so I don't want to do exactly too much. I just kind of wanted to do something small and have fun with it. But anyways. Yes, so this works. But next time we tackle this is actually technically not a proper thing to do. Because first of all, if we go to get exit code thread, it returns a D word. Now what is a D word? On Windows, it's a 32-bit unsigned integer. The astute among you may notice that I've been compiling for 64 bits. So converting an H module into a D word would truncate the result. And so it is technically possible to have an H module that is not null, but because it was truncated to 32 bits, if its lower 32 bits were 0, then that would actually pass this check, and we would have mistakenly thought that the library was correctly loaded, which is not good. Or it's fine, but just like, I would like to take care of these edge cases for sure. And then, yeah, with this load library remote A, we can't really... We can't get the exit code of load library if it does fail, even then, which is not great either. So, what we would... Yeah, so like now what? What we would ideally like to do is, or what I'd ideally like to do, is to actually write just a small bit of shellcode for every architecture that we plan to port this, which maybe that's just x86 and x86, 64 for now. And then ARM should also be kind of straightforward. You just need to do a little bit of grunt work there. But yeah, so we would write a little bit of shellcode in order to both get the actual 64-bit, the actual 64-bit module, and then in addition to that, or 32-bit, it depends on the size of the pointer, but then in addition to that, we get the exit code, so that we're kind of not just shooting in the dark here. We have actual good debugging information for when loading a library goes wrong, and that's nice. But we'll do that next time. For now, I'm just gonna sort of stop here, and yep, I'm gonna commit get an injection working. Okay. And that's it. thank you all so much for watching and hear me rambling. It's been fun. Have a good weekend, you all.